Okay, this is section 3.6, chapter 3, section 6. All right, so this is piecewise functions and shifting vertically and horizontally. All right, the first thing, this is a piecewise function. This is f of x equals both of these equations. The reason it's called piecewise is because the definition of a function says we can't repeat x's. So therefore, we're only using this part, or this equation, when x is less than or equal to 0. We're only using this part when x is greater than 0. See, none of the x's are repeated. So if we're looking for f of 2, then we're going to put 2 in place of x, solve it, we get the ordered pair 2, negative 3. We're looking for negative 6. We're going to put negative 6 in for x. We get negative 12 plus 3, which gives us negative 9, with the ordered pair negative 6, negative 9. We're looking for f of 0. Remember, the 2x plus 3 is where we equal 0, so we're going to plug it in this equation, and we get 3. Remember also that when 0 is in the x position, it's a y-intercept. All right, so now we come here and we graph this equation. Okay? And so what happens here is we're going to graph it by pieces. So I'm going to take each piece separately. So notice I did the 2x plus 3 in red, the negative x minus 1 in purple. But they're both the whole graph. So if I want 2x plus 3, I'm going to start with 3 at the y-intercept, go up 2 and over 1, I get my point here, and I can see that I have a line that's right here. But because I only want to use the x's less than or equal to 0, I'm starting at 0 and taking all the graph right here. In other words, right here where x is greater than 0, I'm not using. So that's the reason I marked it out. On the negative x minus 1, if x is greater than 0, notice I have an open point at 0 because I've already used 0. So there's got to be an open point. If I start with negative 1, go down 1 and over 1, I got my graph here, and here I'm using all the x's that are greater than 0. So just remember, you got to follow this domain for your x's. You can only use this equation if x is 0 or less than. You can only use this equation if x is greater than 0. One of the things you're going to have to do in order to do vertical and horizontal shifts is that in terms of this, you know this equation here, this is y equals x, which is in your slope-intercept form. Actually, y equals x plus 0, straight line. This is y equals x squared. This is going to be a parabola. This is y equals absolute value of x, which is your v. And don't worry about square root of x. I'm not going to give you any of those. So let's look at this. All right, so here's a problem, a graph. See, I've written in red f of x equals x squared. And so see, if I plug 0 in here, I'd get 0, 0. If I plug the negative 1 in here, I get negative 1, 1. If I plug the 1 in here, I get 1, 1. So that's how I got the red graph. Because it's x squared, I knew it was a problem. What happens, though, what if we add directly to the function? The function is x squared. So see how I'm adding 2 directly to x squared. It's called a vertical shift. And all it does is all I'm going to do is add 2 to this y, which shifts it up. Add 2 to this y, which shifts it up. Add 2 to this y, shifts it up. There's my graph. Done. If I subtract 3 directly from the function, the x squared, that means I'm going to subtract 3 from x. I'll subtract 3 here from x, 3 here from x, 3 here from x. Got my graph. So anytime I add or subtract directly to the function is a vertical shift up or down. Horizontal shift is when I add or subtract directly from x, not the function, x. So here's the absolute value function. If I plug 0 in there, I get 0, 0. If I plug negative 1 in there, I get negative 1, 1. If I plug 1 in there, I get 1, 1. Because it's absolute value, it's not a parabola, it's a v. See, if it were x squared, it would be a parabola. Because it's absolute value, it's a v. So what happens here is this. Here we're subtracting 2 directly from x, not from the function, which would have been absolute value of x. So what we do is we pull it out. Pull that x minus 2 out, solve it, we find x equals 2. That's telling us right there we're going to add 2 to all the x's. So I'm going to add 2 this way, 2 this way, 2 this way. There's my v. Here, I have x plus 3. So what's happening here is I put x plus 3 equals 0, subtract the 3 over. This tells me I'm going to subtract 3 from all my x's. So I come up here, I subtract 3 over, subtract 3 over, subtract 3 over. There's my line. So see, anytime I add or subtract directly to x or from x, it is a horizontal shift, left or right. And all I got to do is take that factor out, set it equal to 0, and solve, and it tells me what to do with x. See how it tells me to add 2 to x? See how it tells me to subtract 3 from x? And make sure you understand when we have a vertical shift, we're adding and subtracting to y.